Harar Mahadev. This is the third lecture of Coder Army. In this, we have transistor. What is a transistor? A transistor is a semiconductor device, semiconductor, which has two, which sends the signals. That's it. So a transistor can store one bit. A one bit is a binary. 1 byte is equals to 8 bits. 1024 bytes is equals to 1 KB. 1024 KB is equals to 1 MB. 1024 MB is equals to 1 GB. 2 power 10 GB is equals to 1 terabyte. 2 power 10 terabyte is equals to 1 petabyte. How to store the alphabets? We know how the computer will store the number. First, the number will be converted to binary and it is stored. Okay, but how the alphabets? The computer don't know what is A, what is B, what is C. So for that, they have assigned an ASCII table. Each character have a value in ASCII table. That number is fixed for everyone in the world. Even China, even if it is Korea, even if it is India, Russia, anything. Everybody same ASCII table follows, because if they don't follow the same, there will be a lot of misunderstanding and confusions. So in the ASCII table, each character is assigned a value. Each operation is assigned a value. A is assigned as 65. Then the 65 is converted to binary and it is stored. When we want to retrieve that, the binary is then again it is buried which type of it is. If it is char type, then it will convert into the char. Here we write the first code hash int main. In int main is a function. It is the starting of program main function, and inside the curly braces we write the code. The compiler don't know what is cout. It require header files. It require what is std. It need to understand. For example, sum of two numbers. Using cout 2 plus 3, it will print 5. But if you use double quotes, it will print same, because inside double quotes whatever it is print same as it is. Variables and data types. What is a variable? A variable is the name of a memory location where we store the data. For example, A, B, C, D, Omkar. For example, int age is a variable. Int box is a variable where we store the data. And data type is a type of data which you store in the variable. Can hold. For example, boolean, character, int, string, like that. So first one is int. Integer consists of 4 bytes. Int name equals to 10. The 10 value is assigned to the variable name A. Name is a variable whose type is for which memory allocated is 4 bytes. 4 bytes is equals to 32 bits. 1 byte is equals to 8 bits. Total 2 power 31. Why we are using this much amount of memory? We have set a standard set for integer. Suppose we can use less. Suppose if the number is big, then what? They will increase. So that's why we set a standard set. By default, the compiler know it is int and will read up to 32 bits. Second one is character, which is 1 byte, means 8 bits. The name can be character means one single alphabet. A, B, C, D, not write D, A. It can't write like that. Coming to first is binary form. To understand it is 97. After that, which type? Char, then A. Character contains only single. Next one is float. Float is 4 bytes. It is 32 bits. Float is consists of integer decimal numbers. 1.23, 1.234 like that. And double is 8 bytes. It also consists of decimal number, but it is for big decimal numbers. Can a 40-bit can store in 32-bit? No. Then we'll use long int. Boolean 1 byte, 8 bit. True or false. Which is a memory should be used wisely. How to store negative number? Negative integers like that. -5, -6. How you store? So what we'll do first, we write binary form of that. Then first we'll write the binary form of 2. Then take the 1's complement. This is the binary form of 2. Then take the 1's complement. We will convert 0 to 1, 1 to 0. then add 1, this 2 complement, this is the binary form of minus 2. So how it is stored? If starting is 0, then it is positive. If starting is negative, then starting is 1, then it is negative. Suppose we store a number 8. We store a number in 3 bits. Okay, 3 bits. So how many numbers we can store? 8 numbers. So out of which 4 will be positive, 4 will be positive, and 4 will be negative. Okay, so 0 0 0 0, 0 0 1 1, 0 1 0 2, 0 1 1 3. Here 1 0 0 0, 1 0 1 minus 1, 1 1 0 minus 2, 1 1 1 minus 3. Okay, but what is the problem is that 0 0 is 0, 1 0 0 is 0. So instead of that, we can assign 1 0 0 is minus 4, minus 3, minus 2, minus 1, because it forms a pattern. Okay, here we can see with clarity 2 power 3, 2 power 3. So 0 to 1 2 3, 2 cube, and here minus 1 to minus 4. 0 will be on positive side, minus 1 to minus 4 on negative side. So 32 bit, 2 power 31, 2 power 31, divide equally. Minus 1 to minus 2 power 31, 0 to 2 power 31, minus 1. So this is about the fourth lecture. This third lecture.